Welcome to Review Recording 1A to accompany Instructional Recording 1A for Section 5.3 of Unit 5, Chapter 5, Mathematics 2200. We'll be doing some examples on solving equations with square roots that have variable radicands. Example 1, we solve for all possible values of x. The negative of the square root of x equals x. First thing we do is note that the index is even, so we check for a restriction. So the radicand must be greater than or equal to 0 because our index is even. That means x, in this case, must be greater than or equal to 0. So both 0 and 1 fit that condition. So we haven't really ruled anything out yet. Let's solve the equation itself. We have the radicand already isolated, so we'll just square both sides. And we've got the negative of the square root of x squared. That's going to become positive x, because the square and the square root cancel each other out, and squaring a negative makes it positive. Over on the right-hand side, we have x squared. This is a quadratic, and with quadratics, we make them equal to 0. So we've got x squared minus x equals 0. Take out the common factor of x. We've got x outside of x minus 1. That gives us x equals 0 or x equals 1. Looking good for option B so far, but let's check. So we'll start by putting the 0 in for the x. And we've got the negative of 0 is supposed to equal 0 in that original equation. And 0 equals 0. That's good. X equals 1. We're supposed to have the negative of the square root of 1 equals 1. That gives us negative 1 equals 1. That's false. So x equals 1 is extraneous. It's not a valid root. So the only possible answer here is 0. In example 2, we're told the perimeter of this triangle is 12 units. And we have to algebraically determine the value of x. Now, recognize that root of x minus 9 represents the side of a triangle. So even though the radicand normally would be greater than or equal to 0, we have to say that x minus 9 has to be greater than 0. No equals in this one. Otherwise, if x is equal to 9, we don't even have a triangle. So x will be greater than 9 there for that restriction. And for this one, it has to be greater than 0. Now, we add up our sides, and we have root of x minus 9, because we're working with perimeter, so we add the sides. Root of x minus 9 plus root of x plus 3 is supposed to equal 12. It's a radical equation, so we start by isolating the more complicated-looking radical, which is the root of x minus 9. So we have root of x minus 9 equals 12 minus 3 minus the root of x. 12 minus 3 is 9. So we have root of x minus 9 equals 9 minus root of x. We're now ready to square both sides, because that will get rid of the root right here. So that'll give us x minus 9. On the other side, though, when we square it, we've got to be a little bit more careful. We're going to have to square that by multiplying it by itself, which implies, if you're familiar with FOIL, we have to use FOIL. I call it any binomial. Some of you might use the box method. 9 times 9 is 81. Negative root of x times negative root of x. That's positive x. Then we have negative 9 root of x here for this multiplication, and then another negative 9 root of x for that multiplication. So we've got x minus 9 equals all that. I'll rearrange things to get like terms together. This x can come over with this x. So I'll have x minus 9. The 81 comes over with that, becomes minus 81, equals, these two are like terms, negative 18 root x. X minus x, that's gone. We've got negative 90 right here equals negative 18 root x. I can divide both sides by negative 18, like so. That gives me 5 equals root x. I square both sides, and I get 25 equals x. We can check that. Square root of 25 here would be 5. 25 minus 9 here is 16. Square root of 16 is 4. So we have sides of 5, 4. 5 and 4 is 9, plus 3 is 12. So an x value of 25 gives us the correct perimeter. In conclusion, when solving radical equations with variable radicands, we determine restrictions on the variable, isolate the radical, the more complicated one if there are two or more radicals. We square both sides. If a radical remains, isolate it and repeat the above steps. Then we solve the equation and check for extraneous roots.